Right. Hello, everyone. It's a good time to get going. Sorry, we're just running about a minute late. Hello, everyone, and welcome to today's webinar session with SORACOM. Today, we're going to be talking about EV infrastructure rollouts done the right way. I know it's a really busy time for everyone on this call. Just want to say thank you, first of all, for all of you for being here. It's really great to see that we have so many people with us today. There's going to be lots of opportunities today to discuss everything you would want to know about EV charge, IoT's role within the world of EV charge, and we have some genuine thought leaders and experts with us today who are going to help answer any questions you've got as well over the next 45 minutes or so. So let's make a very quick start. Hello, my name is Duncan. I head up the marketing team here at SORACOM. But don't worry, you're not going to be hearing too much from me today. Actually, we've got a couple of really great speakers for you today. First of all, we have Petar Georgiev, who is head of strategy and partnerships at Ampeco. He is a seasoned EV charge expert, I think it's fair to say. He works for Ampeco, which is a charging management platform for EV vehicles. Petar himself was the 2021 winner of the EV Stars Under 30 award. And he's also among the 2022 class of Forbes Bulgaria 30 Under 30, ranking in science, tech, and healthcare. Hey there, Petar. How are you doing?
Hi, Duncan. Great to be here with you today.
Thank you so much for joining us. Really looking forward to hearing your presentation in a few moments. And we've also got Yiro. So we've got Yiro Zong, who works with us here at SORACOM. Yiro is an M2M and IoT specialist. She's been in the industry for about 20 years in telecommunications. She works with us as a sales development manager and really bridges that gap between the language gap between the IoT technology and the industry needs. And she's really focused on net zero topics, covering everything from utilities, environments, cities, you name it. And she's got some really great insights to share in a moment about IoT's role in EV charge. So hi there, Yiro. Good to see you. Thanks so much for being here.
Thank you for having me. Really excited to share.
Awesome. Great stuff. Okay, well, listen, let's not hang about too much. We've got quite a few things to get through today. I just want to spend 60 seconds just giving a little bit of background to everyone attending today, who we are at SORACOM, why are we even hosting this topic of conversation today, what's the context for us being here. SORACOM itself is it's an IoT connectivity platform that helps businesses who are launching IoT developments launch into the market. We provide reliable, affordable IoT connectivity that makes it very easy to connect any number of devices from anywhere in the world over cellular connectivity. Our background is we were founded in Japan in 2015 by former AWS and telco veterans. And today we've got physical offices in Tokyo, Seattle, London, and actually our team is distributed globally all over the world. We serve more than 20,000 startups, SMBs, global enterprises across every industry you can think of: agriculture, EV, energy, construction, you name it. And in fact, you'll find a SORACOM SIM card in over 4 million devices globally. We're financially supported by KDDI in Japan, and we actually have capital investment from other technology innovators like Hitachi, SEACOM, and Sony, amongst others. So that's just a very, very brief snapshot of who we are, and just to add some context around why we're presenting today. If you do want to learn anything more about SORACOM, we've got a couple of members of our team on the call today in the live chat. So we have Nicola, and I believe Camilla has joined us as well. So if you do want to ask any questions, not just about SORACOM, but about anything that's presented today by Petar, by Yiro, anything that comes up, please do use that live chat feature in the Demio portal just to raise those questions. I promise we'll get to as many of those as we can before the end of the session. Okay, I think that's enough from me for the time being. So yeah, just a reminder, use that Q&A, use that chat box for any questions you've got, and we will get to the Q&A at the end. But for now, I'll be quiet and I'll hand over to Petar for the first part of the presentation. So Petar, over to you.
Yeah, thanks, Duncan. And yeah, hello, everyone from my end. I have prepared a really interesting presentation for you today, and I hope you find it interesting. But I tried to really, explain a bit more about today's landscape in EV charging, and also some of the main challenges along the way, and also how they open opportunities for companies in the whole ecosystem. So if we can go to the next slide, please. Today's topic is really also with an outlook to what comes next. The electric vehicle transformation and the transition to cleaner mobility is already happening. We now see even faster pace of how that happens. So it would be really interesting to hear also your viewpoint. So indeed, don't hesitate to use the chat section for any comments you may have. So the next slide, please. Today's agenda is broken down into several different aspects. So first, I'm going to talk about the EV charging market, the landscape and the outlook. Then I will cover the different roles and market models in the EV charging ecosystem and the interactions that we see there. And I will also focus a bit on the deployment challenges with regards to charging. That can be quite broad, obviously, but I'll try to narrow it down to a few things in particular. Next slide, please. So a bit about myself and also the company I work for. Duncan kindly mentioned in the beginning, so I won't spend time on that. But with the next slide, I wanted to show you a bit more on who I actually represent. So I work at Ampeco, and we are a white labeled CPMS, or Charge Point Management Platform, software solution that is cloud-based. And in the next slide, you'll be able to see some of the functionalities, the features that we enable. So if you can go to the next slide. You can see here some of the features that our management software enables, and that I'm sharing just to give you a bit of a context about the things that I'm going to talk later in my presentation. As you can see, I come from a very specific industry niche of providing those solutions to charging point operators, and we do that globally. As you can see on the next slide, we have more than 50,000 chargers connected to our system, with really different markets represented, from the European market and the UK market, then going into the APAC region and North America, but also some other parts of the world. And we see not just the charging points that are connected, but also the number of sessions that we experienced only last year. I would imagine this number would be times bigger this year, and that's also a trend that we'll see growing more and more in the business in general. So in the next slide, you'll see why I mean that. The EV sales, to begin with, we see the global EV fleet really growing in the next years, and that's driven by several different factors. I mean, it's true that there's the policy element of it, where governments are pushing in that direction, right? There's also the technology is maturing in a way. Supply chains are consolidating, and we now see the battery supply chain being linked to also several manufacturers that are creating deals to secure supplies for batteries, and then scaling up that production, making vehicles more affordable. This is all going to result in really major increase over the next years, and that's just a short outlook here until 2025. Just to demonstrate also how the markets are being distributed. We see really quite a lot of vehicles being sold in China and Europe. The US is also catching up, but we'll see also other major markets like Canada, Japan, India, of course, grow even further going into the next decade and also going towards 2050. But also you see how that is demonstrated in terms of the share of sales of new cars across those same markets. We see that right now in 2021, 2022, 1 out of 5 cars in Europe is electric that's being sold, and this will be 2 out of 5 in a couple of years' time. So I think we're really on the cusp of that transformation, as they say, at the bottom of the hockey stick, and I think the only way from here is up. And we see that on the next slide also in terms of the numbers for EV charging. That's a different sort of view here that you see with several different scenarios according to Bloomberg New Energy Finance. One is regarding the economic transition, the other one about the net zero transition. So in the ETS bars, you would see what is economically feasible And in the net zero, you would see what's the real optimum need to get where we want to by 2040, by 2050, if we want to go on a net zero path for the whole economy, and transport's role in it clearly in the case of EV charging. So here the global network, that's millions and millions of connectors. We see also an interesting distribution. Most of them will be in home. Some will be also at work. Public slow and public fast, that's essentially the chargers that are on street next to houses that don't really have a driving lane where to park the vehicle and charge it. Public fast, those are the chargers which essentially would be on the highways, and we see that there are not that many in terms of the number of connectors. And that would also mean a lot of investment. And you see also in terms of e-bus and e-trucks, we expect them to grow also quite a lot in numbers as production ramps up. So yeah, we're also going to need a lot of investment in that. But you see how the investment in home isn't really that much, and there's a lot of benefits to that. Luckily, what we see on the next slide, for example, is that really charging happens in well, three main locations, but first and mostly, it happens in the residential setting. Some studies suggest that anything between 60 or 80% of the charging happens there. And this is something that will also persist in the next years, according to several different reports from the IEA to also IRENE, which is, again, an international body that looks into renewables and smart charging. But then going to workplace and fleet, that's also where we're going to see a lot of vehicles being charged. And the main reason is also the longer dwell time there as well. And then also the last aspect, let's not, of course, miss that point, which is the public charging. This is the charging that will happen when you need to do a long journey for the most part. And this will be also very fast power charging. So what does that mean for the business of EV charging? That's also what I wanted to highlight now. So on the next slide, I'll try to showcase not just the residential workplace and fleet and then public, but delve into them a bit deeper and show the use cases that we see in those larger groups. So starting with, I would say first the home charging, as this is where most of the charging happens. I think in that case, you have longer dwell time that allows to enable the flexibility needed to provide additional services to the grid, or the ability for the consumer, for the EV driver, to charge at a cheaper rate. Then some of those drivers will not have that possibility. So for them, we need to consider the on-street charging. This is something that can be in the public domain and at the same time used by the driver as if that's their own charger. And there are different ways to do it. A company in the UK called Connected Curb are doing a very interesting project on that. At the same time, there's a couple of companies, again, in the UK. One of them is called Just Park, which is about sharing chargers. So again, it's a very interesting range between where home and on-street starts, because there are some solutions in the middle. And then a lot of companies like housing associations end up using those chargers as well and providing them as a service to their customers. A lot of charging will happen at work as well. As I mentioned, we spent a lot of time there, and charging at work can actually align really well with the peaks of solar generation that are during the day, especially in cases where we do have commercial buildings now more and more required by policy, but also by economics to install PVs at their rooftops. And those PVs, those photovoltaics, they will really feed into the vehicles, and they have to be targeted through the use of smart charging to be utilized when we need them the most. So that also happens through real-time data analysis. We look at the data that is available, the prognosis, the mix of the the grid and the electricity sources that are in the grid, and estimate the ideal way to charge those cars. In a way, the same goes for the next use case that I wanted to highlight, which, yeah, if you can see it. Exactly, the car parking. So in the case of car parkings, we have similarities to the work charging in a way that it's, again, considered a depot-like charging. Then I wanted to highlight two more. One of them is the destination charging. There we don't have really a lot of capacity for flexibility, but we really don't need it because the idea with fast charging is really to use primarily, fast and ultra fast charging to enable longer range journeys and sometimes, tourism. But also there we need to look at the grid connection a bit more in detail, because it might need to be enhanced by on-site storage. It might need additional grid upgrades that oftentimes for charging point operators take a lot of time, and not necessarily they have the time needed. And also the business case for the destination charging is linked to a longer period of usage because of the utilization rates, because of the high capex investment that you ultimately make in that infrastructure. You need a longer period to break even, essentially. So right now we see a lot of companies just putting chargers with the idea that, we'll have EVs coming down the road. Maybe now we won't be making money, but down the road we will. And they're betting on that. So only now with the increased rate of EV rollout, we will see more and more utilization rate on those chargers. So yeah, there's some to be said about the business model there, and the tenders and the durations of those tenders. And then the last one is the depot charging. Again, some similarities to what we see in the context of work charging of car parking, but also corporate fleets or last mile delivery fleets. They have different needs in terms of the functionalities that you need to integrate in that context. So you need to look at different telematics and routing specificities, but also the ability to integrate seamlessly EV charging into the fleet software. So that's something that a lot of those big companies that are doing deliveries that probably you've used in the last month, that's what they will need. And indeed, there's a lot to be discussed in all those 6 cases. And that, in a way, has to do with location. And in the next slide, I wanted to even further elaborate, not just the use cases define the business model, but primarily the location. And I wanted to highlight 3 main variables that we see universally, really, from our perspective as a management software provider for chargers. We really see it everywhere. So first, we have the type of charger. Here, we're looking at from anything from 3 kilowatt to even 350 now that some cars are able to take. Then, secondly, we look at the motivation for installation. There's different reasons why businesses want to go into EV charging, and they look at the location in order to find the right fit for their business model. And the third one is the grid connection and grid services. I alluded a bit to the fact that sometimes when you want to have fast chargers, you need to make sure you have the right grid capacity next to them. Otherwise, it could be getting too costly for you. And also at the same time, in the home charging business, you do have different types of flexibility ancillary services that can be provided to the grid. And that brings the following considerations. I mentioned already the longer dwell time and the charging speed. So the type of charger would mean that if you choose a slow charger, I mean, it's probably logical what I'm saying, but you need to have a longer dwell time in order to also, enable the grid services. But, generally, it's a compromise on charging speed. So if you have a slower charger, you agree as a driver to use it longer and at a slower speed. and vice versa. If you just plug in for 15 minutes, you need that faster charger. And that's the really the first moment where you start to look at the business model. Then it goes further because the motivation covers aspects like, does your business want to cover a longer area, a wider area, so that drivers don't have range anxiety? Or your business is more towards revenue generation from the point of view of providing different perks to the consumers, or providing your charging business as an added value. What I mean here, for example, is, do you want to be in the context of supermarket chains? Do you want to have chargers at your location? It's not necessarily from the point of view of coverage, but really you want to have additional revenue generation from people charging and then shopping at your place. Same goes for hotels, any type of tourism. So that's the second consideration I would highlight here. And the third one is when it comes to the grid connections, if you want to extend, there's several studies pointing different numbers in different countries, so I guess it depends, but in Lithuania, it was something about 7,000 euros per meter of cable extension. And you don't want that. If you have to extend by a kilometer, that's a monumental sum that you don't want to spend. So you have to rethink, okay, maybe I'm not going to put the charger here. And that's actually one of the reasons why now also in Europe, at least, that I'm aware of, policymakers started to look at those capacity maps of the medium voltage grid, of the high voltage grid, and try to align the so-called transportation corridors, the 10T corridors in Europe, to align the chargers that they're going to put there with the respective electricity that's available close to them, so that businesses can have ultimately easier and cheaper sort of solution that they offer in the market. And in the context of home charging, I already mentioned the flexibility potential, not just in the context of load management and peak shaving, but also down the road when standards allow it, because there are standards and protocols governing all that. Also vehicle to grid. So that's also something that is a strong consideration for the business model, and also makes you choose the right brands of chargers, the chargers that can support everything, or the infrastructure that you need to integrate with that. And in the end of the day, it's a big ecosystem. And as we can see on the next slide, am I frozen or is it just me?
No, you're fine. You're doing great, Petar. Yeah.
All right. So just
you can see the new slide now with your orange template. Just before you get into that, Petar, I did have a quick question. I hope you don't mind me interrupting. You mentioned an acronym earlier on, PV. Could you just explain what PV is and what it means?
Yeah, photovoltaics. So I mentioned after that, it's photovoltaics. Yeah. So it's the solar panels that we have on the rooftops.
Cool. Okay.
Yeah. So here I'm going to throw a few other acronyms at you, but I'm not going to really focus on explaining that slide. I just wanted to showcase the different roles in the EV charging ecosystem as described by Charge Up Europe, which is the voice in Brussels of a lot of charging point operators. And the so-called charging point operator, the CPOs, they have quite a lot of responsibilities. And what we do at Tempeco is that we provide them the software to enable all the services that they want to provide. It could be user management, tariff management, energy management, roaming, and all that happens through different integrations. So all those companies need to be talking to each other. And there's a whole bunch others that enable different things. In your case, what you also do is part of that ecosystem. It's more on the side of the hardware and related to that, the integration with software. But it's a really complex ecosystem, and everyone has to talk in order to really achieve the optimized charging experience. And I wanted to show you on the next slide how we kind of imagine that from our perspective. So think of a building, and next to that building, you have vehicles parked. So you want to charge those vehicles and give them the right amount of power, and manage the load. So by managing the load, it's really the so-called dynamic load management that is, it's a feature that can be achieved with limiting the power that is given to the vehicles. That can be static, that can be dynamic. It can be just shifting to to the next period when more power will be available, and understanding the building. Then the dynamic load management also includes the battery. So on the one hand, you have the battery storage. On the other, you have the photovoltaics that really make the building a smart building. And indeed, that is ultimately governed by a back office. And in that back office, you have all those different components getting together, talking to each other through a language of common protocols. And on top of that, you have a very interesting possibility to further integrate different type of analytics and data. And that's really what gives a lot of value to businesses, not just to the drivers. Ultimately, the idea is to get everything as affordable as possible and get costs down. But that also happens through and only through business collaboration. So what we see, for example, as features being added on top is forecasts that could be related to the weather, could be related to the electricity mix. In some markets, there's the possibility to contact energy utilities and exchange data with energy utilities so that they can also optimize their business. The situation that we kind of see on the left-hand side, the so-called smart building, it ultimately gives a really fertile ground to experiment with virtual power plants as well. That's especially for bigger buildings that have bigger capacity. And as I mentioned, also with fleets that are parked next to buildings, the use of telematics and fleet logistics software that gives insights on how to operate your business are even making it a complete picture. And if we, I hope we can see all the elements on the slide now. There's a few others, basically what I was referring to. Yeah, so now that we look at this, it's, sometimes too easy to think, okay, let's take a successful pilot in country A and apply it globally. Well, it would be great if we could, but there's not really a one-size-fits-all solution for EV charging. And that really shows the need for that flexibility to integrate with different elements and add what is needed for different markets. Quite often, this is driven by regulation. But on the next slide, I wanted to highlight a few other points. Yeah, exactly. So the living arrangement and demographics differ in countries. We all know how countries like the Netherlands and Australia will compare in this regard. Then also looking at the vehicle type and the vehicle use, also we see different patterns across different geographies. So it's really important to have that understanding of the market if you want to really roll out EV charging infrastructure that is suitable for a particular area. I mentioned the grid capacity, I won't focus on that, but also the stage of EV deployment is quite important. I'm just going to give an anecdotal example. I was talking a few years ago already to some people in Norway that had installed, at the time, considered fast charging of 50 kilowatts at a location that they considered to be very, very prominent, very important as a corridor, and they needed that charger there. But they installed it in 2015 when there were no vehicles, and still Norway was way ahead. It's not where it is now in terms of the sales. Now it's like 85–90% of all sales are electric. But at the time it wasn't the case, and still that was the business decision. But then with the growth of the market, it was evident that this charger is not needed and is not used, and instead a whole different corridor was created, and a lot of people were charging in home and residential settings. So in fact, the utilization rate of this charger did not increase, and they have to decommission it and move it, which is a costly exercise, as you can imagine. But it shows really how the stage of the EV deployment is a very important consideration, knowing how the market will mature and understanding the above conditions, and also urban planning and the transportation policies that we see locally and also at a broader level, for example, in Europe through the European Union. Those ultimately impact the business decision, how and where to put your charger. And I wanted to focus here a bit more while we're on this slide on the transportation policy. I mean, just last night, there was an agreement by EU leaders as represented in the council where all the ministers meet. There was a decision to really ban the sale of new combustion engines post 2035. Previously, the European Parliament agreed to that, and essentially the two institutions are the co-decision parties in the EU, and the European Commission has already proposed that what they agreed upon. So now it's more than clear that we will not see the sales of those vehicles in 13 years. Of course, we need to look at the secondary market, and fleets are a very good opportunity to speed up the battery electric vehicles entry into market. But in the end, it's really, that type of policy that gives signals to OEMs, so the producers of the vehicles. It also gives signals to companies that want to invest into charging. But then once they do that, then different countries have really different policies on EV charging. And that's what I want to show in the next slide. You would see here a map, and the colors don't really matter. It's just to see the different countries. But there was a recent analysis by the Regulatory Assistance Project of about 140 different smart charging tariffs in Europe. And what really struck me as a glaring gap in Europe is that 1/3 of the markets that were examined, so 19 out of 31 countries actually only support that type of smart charging tariffs through their legislation, or rather the rest, so 12 countries out of those 31 don't allow for this type of services to emerge on the market. So it's really about stifling innovation here. And instead, governments have to put supportive legislation to, especially here in this context, allow the basis for flexibility. But then, we see also other troubling developments that could be solved, and I'll say how, but just to mention a few. In Germany, you have the so-called Eichrecht, which is a Germany-specific regulation. In Portugal, you have MobiE, which is about roaming, and I won't go into the details of those. There's a few other markets that have their own specifics that require, especially on the hardware side of things, manufacturers to create a completely different product line. Or, as we have right now in the UK, the upcoming smart charging regulations, they require both software and hardware providers a way to improve their product, which is good. It's in the right direction. It's the right type of policy that is really proposed. But it will be a problem if a neighboring country, let's say Ireland in that case, decides to do something completely different. And this ultimately can create barriers for the drivers, but it's really about slowing down businesses to roll out infrastructure. So what I would really plead here is to have a harmonized framework, and Europe is going in that direction through the alternative fuels infrastructure regulation, which is now being discussed by the policymakers in Brussels. And I really hope that we will be able to get to a really harmonized single market, which is an open market with the use of open protocols and open standards, and a market that supports innovation. And I think once we have that as a direction, just to think in that direction, I think is already important to build a really good experience for the drivers. I think I'll finish here, but I'll be happy to to try and answer some of your questions. And thank you again for your attention.
Thank you, Pascal. That was great. Thank you so much for going into so much detail, all of that. Really, what was really amazing to me is how many variables there are when it comes to EV charging. There's so many different considerations to make when it comes to your rollout. You showed the map on the previous slide there, but do you feel that there's one country in particular that's maybe leading the way compared to the rest of Europe?
Well, I would say in different aspects, you have different countries that are leading, but clearly Norway is a major leader in that category when it comes to EV charging. Also in the Netherlands, we see a lot of flexibility being enabled through the role of different actors, enabling different smart charging tariffs, vehicle to grid. But also the market there, for example, in the Netherlands allows that to happen. So it's really about also not thinking in silos about electric vehicles, therefore transportation. No, it's really electric vehicles are part of the power markets. And in the cases that are kind of outliers, but in the Faroe Islands, for example, there's a project about leveraging the vehicles as frequency reserve, just because they're not connected to the continental grid. And this is really showing how much vehicles are integrated into the power system and how much they can be if needed. So yeah, it's not just transport here.
Well, we're going to save some time at the end for more questions for Petter, but for now we'll just pause and say again, thanks again, Petter, fantastic presentation. If you have any questions about anything Petter presented there, or anything that is even outside of that presentation, please do throw those questions into the chat here in Demio, and I promise you we'll get to those in a few moments. I want to bring in Jiro now. You've been very quiet for the last half an hour or so, Jiro. So thanks for your patience. Because I think what I found interesting in Petter's presentation is, yes, at-home solutions make up a bulk of EV charging. But actually, there's this whole world that requires connectivity and EV charge connectivity sort of outside of the home and work environment as well. And I think your presentation is going to talk a little bit more about the sort of the smart side of EV charge. Is that correct, Jiro?
Yeah, that's right. And I think today's webinar is really timely because as Petter mentioned, the UK's electric vehicle smart charge point regulations are going to come on tomorrow, even though it was kind of dated 2021. And what is interesting, and from today's webinar, I am kind of bringing in the IoT perspective on the role of IoT in EV charging infrastructure. So kind of taking a step back with the upcoming regulation in the UK, there is a requirement that it is talking about smart, but what does smart mean? And I think as Petter mentioned earlier, the majority of charging happens either at home or at your workplaces. And also he kind of talked about smart where it's kind of bi-directional electricity flow between the EV itself and the grid. And I think from our perspective of IoT, it is really enabling kind of a bi-directional communications between the charge point and the cloud. And so effectively this regulation is saying, let's make the charge point communicate with the server so that it is able to then also communicate signals back to the grid. And what this picture is trying to show is the office and the residential homes, which is where this regulation require for all new chargers installed at residential homes and offices to be smart. And what this means is data communications. It doesn't actually say you must use a particular type of connectivity. So you can use your standard Wi-Fi that you have at home anyway, or you could also consider cellular. You would also have the possibility of making sure the charger has automatic meter reading so that it is able to do the smart metering and smart grid capabilities, which is being able to shift your load, whether it's happening now or you are required to randomize the start time so that it doesn't suddenly everybody comes home at 5 and then you kind of shock the grid with all the demands into the electric vehicle. And I think what is interesting here is we need to have connectivity to actually facilitate all these automatic actions. And this could apply to whether it is managing the charge point, knowing whether your charge point is available, but also facilitating if there's something wrong that I can see, oh, this is not behaving as it should. Should I already send a field engineer to the field, or should I kind of investigate to determine, can I do something remotely, or do I need to kind of escalate and have the field engineers to do it? And at that point, you would want the field engineer to be empowered with all the information that is needed so that you're actually doing the maintenance in one go as opposed to having several trips. And from my personal experience of trying to make my smart electricity meter connect to the server, I would say that I've installed them in September 2021, and I am still not connected, and it's such a sore point. But the point is about the field engineer sending them, knowing what they need instead of having this back and forth and rescheduling.
What's IoT's role there? Is it more around sensor detection and just using smart inputs to work out when action is required, or is it something else?
Yeah, I think fundamentally is having the data communications between the charge point and your server. And that's a requirement as stated in this 2021 long regulation. But also, it also specify some of the security related requirements. You don't need to have them by tomorrow, but it is going to come on at the end of the year. And I think now is a good time to actually start thinking, how could you be facilitating the ability to know what's happening in your charge point infrastructure, but also having the ability to know what's happening and then do something about it. I think if maybe we can go to the next slide. Essentially, we are saying the IoT, because you are able to have remote access to the charge point, you can do a variety of things. And as Peter mentioned, it is about the real-time data and analysis that allows you to do simple things. So from the easy ability to know whether it's available, whether it is happening, to the fact that if I know something is not behaving right from my platform, cloud-based platform, I have the ability to say, I automatically shut down, so a trigger, an alert happens and I trigger an event, or the person managing the console can say, this is something's happening, I escalate, and then I say, maybe this needs to be shut down so we can kind of do something about it. Besides that as well, I think coming back to one of my favorite topics, which is IoT security, is we really don't need to have a lot of new security software and solutions. Through your standard IoT connectivity management platform or even device management capabilities, you can straight away know what's happening, and then you can start inferring the status of your charge points. I think this is very important because at the end of the day, we do not want to, impose. And that's one of the good things about the regulation. It doesn't actually say what you need to do. It just says the end outcome is to have a secure charge point. We actually then say, depending on what your requirements are and how you have deployed, maybe you have deployed charge points sold in 2018, how are you going to manage all these different iterations? And our IoT should be able to say, I'm able to look into your previous investment. You don't need to have new capex to kind of invest and then throw out your old deployments. We actually can have all the incremental capabilities that also doesn't have any burden on your designed device. And actually all of this happens in the cloud so that you're able to provide layered security activities so that at the end of the day, you are not depending on one single solution to make sure you are secure and demonstrate you have practiced good security hygiene. So I think at the end, we want to say IoT, by connecting the charge points to the server, you can actually derive a lot of data that allows you to achieve several of your business goals as stated by the regulation.
Thank you for sharing that insight. Do you think when you're choosing IoT to help you with the regulations, is there like how do you make the right decision between, say, cellular connectivity versus Wi-Fi?
So this is this always feels like a loaded question, and I always say that I am not here to, say, oh, you must use cellular or you must use Wi-Fi. I really think it is up to the customer or the enterprise, and I think as Petter says, there is no one size fits all. Everyone actually has their own existing architecture. Are they in Azure? Are they primarily in Azure? Basic things like what is their cloud environment? To actually, we are all very well versed with Wi-Fi, and that's how they go with it. So our solution, and any good IoT service provider should say, we can actually work with your existing environment, and let's look at. So you're saying my devices are kind of lacking in computing capabilities. We don't really want to further overload our device. We want to have relative easy integration into management software capabilities like Impeccos. What can we do with it? And I think the ecosystem is important. And from kind of SORACOM's perspective, we kind of say we can work with your constraints and your business goals, and then we can see what happens, what can we offer from there. But essentially, we want to make it easy to integrate and actually tap into the wider EV charging ecosystem, so that we link to the billing and billing capabilities that Impeco has, and they facilitate EV roaming capabilities. Right. So in that end, we don't want to dictate. We say what you have and what we can work with.
That's great. Thanks, Yuri. Well, we're coming up to the final 10 minutes or so of time allotted, and we've got a few questions here. Great questions, guys. Thanks so much for giving us those questions. Please do add anything into the chat box if you want, and we'll try and get to them in the next 10 minutes or so. I'm just going to, I'll just stop sharing the screen for a second. So just starting from the bottom down. So Stephen, you asked at the very beginning, is this going to be shared, this presentation going to be shared? Yes, it will be. So everybody who has registered for this webinar, whether you've joined us live or not, will get a recording of this session and a link to the presentation slides. There's a message here from Kieran, who's actually based out in Japan, and he's got a question for you, Petar. So he says, in Japan, there are around 57,000 convenience stores who are theoretically potential EV station providers. He says, if all of those convenience stores are eager to introduce EV stations respectively, construction and maintenance of these stations will increase electricity consumption in turn. How should the station installation be optimized considering these commercial players apart from petrol stations? So I wondered if you had any thoughts on that question.
Yeah, absolutely. Thanks for the quite interesting question. I think we will see a lot of those supermarkets, not all of them, but quite a lot of them turning into, indeed, as you mentioned, EV providers, EV station providers. What we'll see is probably slower charging, that is in the realm of 7 or 11 kilowatts, and also managed charging. So you won't be really able to get a lot of electricity there, unless some of those chargers are ultra fast and you just go there and you tap into the charger for 10 minutes, knowing that you'll leave in 10 minutes, and also understanding that if you don't pick up your car, you get penalty fees for that. So there's quite a lot of opportunities to fully utilize those supermarkets, especially with the consideration of, as I mentioned, photovoltaics, so solar panel installations on top. So I think we'll see more and more of them indeed becoming serious players.
Great question. Okay, thank you, Petar. And there's actually a follow-on question about the Impeco platform. Is the Impeco platform compliant with the new UK smart charge regulations, Petar?
Yeah, actually, the regulations, as stated, for the most part, they cover the private charging. And in that context, they're very similar to the previous OZEV grant, which was given for smart chargers that are to be connected. So the functionalities that are being asked to be supported from the software side are really okay. It's really about the hardware vendors that also have to enable those profiles. And here, of course, we're talking about OSPP, connected chargers. But from the software side of things, there's no real hurdles, for the operation of those chargers.
Great. Question here from Imed. Yura, maybe this is one for you, or Petter, step in if you feel you can answer. So Imed asks, just one question. Do you think that edge computing has a role to play in the EV charging infra? Any thoughts on edge computing, guys?
I can say a few words, but I wouldn't claim to be an expert in edge computing. But if I understand it properly, it is the fact that could we make kind of edge devices? So whether it's your sensors in the house or your EV as an edge device where you can have computing capabilities and run all those machine learning algorithms and so on. So from that perspective, I can imagine that the EV, it already has a lot of machine learning algorithms for managing the battery device. And if we think that with the EV regulations, we are having future views on increasing grid flexibility, then we would need not only the EV itself, but maybe dumber, less computing heavy energy assets, whether it's my solar panels compared to EVs, or whether just an energy storage or heat pump. How would they kind of contribute to a flexible grid? So I think that would be essential in order to make sure you don't kind of overrun. You can actually facilitate dynamic load management of the grid.
Oh, thanks, Yura. Yeah. Anything to add there, Petter, on edge computing? No. Fantastic. The last one we've got here is from Colin. It's another one for Petter. So Colin says, so many platforms say they're the easiest to integrate when it comes to an EV charge point. Can you share any key requirements that are actually essential for charge point operators?
Key requirements that?
So what would the kind of main key requirements be when you are deploying an EV charge solution at scale?
All right. So perhaps starting with the business model itself, I think what a company that starts need to understand is what type of challenges they'll have along the way of their deployment, and discuss the whole context of setting up their charging business. Then I think it's quite relevant to look at how you integrate all those different pieces that you need, and what's the basis for it. So ideally, a platform should allow to have those different features being added, be it a specific requirement for smart charging in a given market, or specific tariff reimbursement. This has to be very easily integrated. So this is something that I would here also flag. But yeah, perhaps also one other thing is when it comes to operating a business, we see a lot of providers in the market that are using proprietary technology or proprietary protocols. Those are slowly being phased out, because also they see where the trend is going. But as much as possible, CPOs should be in control of their business. That, from my point of view, also includes processing of payments, and different fees that are being added to the bill. For example, there's a lot of platforms that charge, for example, for a fee per transaction. That's something not a lot today, but when you ramp up your chargers, it will be. So probably won't be as good as a business idea. So yeah, there's different elements, I think, but understanding the business model and your progression down the road is very important, so that you make your balance sheets add up.
Well, it comes to the end of the questions that we've been given. Thanks so much to everyone for throwing some questions at Petter and Yuri there. Really great things that came up there. And we're kind of at time, so just time for me to quickly wrap up here. So I guess all that really remains for me to say is a big thank you to Petter and Yuri for preparing two great presentations. Thanks so much, guys. We really appreciate it. And now it's over to you guys joining us today and watching this on demand. It's your turn to take charge. SORACOM can help in a number of ways. We've got a number of articles that can help you understand a little bit more on the EV charge market. We've recently published content around OCPP, why that's important for EV charge solutions. We've got content around ways to structure your EV charging infrastructure. And we've also got content around IoT connected charging stations for EV adoption. If you're ready to take the next step and interested in understanding not only just EV charge, but also IoT's role within EV, then we have a team of experts here at SORACOM who can help. So you can just visit soracom.io to discover more about the broad range of use cases that we support and the ways that we can help in different areas of your business. That is it. So once again, thanks so much to Petter and Yuri for joining. Remember, if anyone here has any kind of questions about SORACOM or anything they want to know about IoT in general, visit soracom.io and we've got a team of experts that are ready to speak with you. That brings us to the end. So I'm just going to say once again, a big thank you, and we'll hopefully see you at another SORACOM webinar in the very near future. So thanks very much, everyone. Goodbye.